Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. This video will be looking at problem number 5, which gives us two equations, y equals 18 and y equals -3 times x minus 18 squared plus 15. And we're asked, if the given equations are graphed in the xy plane, how many points do the graphs of the equations intersect? Exactly 1, exactly 2, infinitely many, or 0. So we have two equations, and the first one is a line, but not just any line, it is a constant line. And so constant lines, if we have our xy plane, they look like a single horizontal line where every input is mapped to the same output. In this case, that is y equals 18. And then our second equation is a quadratic. And quadratics are parabolas. And they can open upwards or downwards. They can have their vertexes in all bunch of places, but they all generally have this form. And whenever we have a line and a quadratic together, there's only three options for how many times they can intersect. They could intersect at two places. They could intersect at 0 places, or they could intersect at exactly the vertex and be one spot. So those are our options of what we could find. So in order to figure this out, we need to know, is the value of this line, which is just the value 18, is that within the range of our quadratic? And if so, is it at exactly the vertex or not? So to figure out the range of our equation, we need to know two things. We need to know if it opens up or opens down, and we need to know where is the vertex. Fortunately, the equation that we are given is y equals -3 times x minus 18 squared plus 15 is given to us in vertex form, which means the value of our vertex is already here in plain sight in our equation. In this equation, the vertex is at the point 18, 15. And we can see from the sign of the coefficient that this is a negative parabola, in which case it means it opens downwards. So in other words, the graph of this equation is going to start at the point 18, 15, and it's going to open downwards from there. Which means that our range is going to be every value from the y value of our vertex, which is 15, all the way down to -infinity. And so you can see, if we were to graph our equation y equals 18, it would come across here and be at the value of 18 for every y value, and it would in fact not intersect with our parabola at all. Now it seems like this question is trying to trick us, because when we look to see how many times these equations intersect, the only thing that really matters is whether our constant value, which is 18, is within the range of our parabola, and if so, is it at the vertex? Which means the only thing we need to know is the y values. 18 is the value of our constant. The range of our parabola is everything from 15 down to -infinity, so they in fact do not overlap, and these two equations do not intersect. And so it may be tempting to see this 18 in the x value of our vertex, and to think that that is somehow relevant to the constant value of our horizontal line equation. But this is in fact a red herring and has no bearing on the answer whatsoever. So when looking at this problem, we can see very clearly that the lines do not intersect, and therefore our answer for how many times they intersect is D, 0. Now this is one way to solve this problem, and this will get you the correct answer. But I also want to show another way to solve this problem in case you'd rather think about it algebraically as opposed to graphically. So I'm going to move this up here, and let's look at how we would look at this problem another way. When we ask whether these two graphs intersect, that's another way of asking, would these two equations ever equal each other? And so we can just set them equal to each other and see if there are any values of x which will cause these to equal. So if we have 18 equals negative 3x minus 18 squared plus 15, we can start off by subtracting 15 from both sides. And we would get, I'll write this over here, 3 equals negative 3 times x minus 18 squared. We can now divide both sides by negative 3, and we will get negative 1 equals x minus 18 squared. And now we can try to take the square root of both sides. If we take the square root of both sides, on the right side we would end up with x minus 18. But on the left side we would have the square root of negative 1, which is not a real number. You cannot take the square root of a negative number and produce a real answer, which means there's no place on a graph of the real numbers where these two would intersect. In other words, there's no value that you can square to get negative 1, and therefore these lines do not intersect. I hope that was helpful to see two different ways of looking at this problem. Thank you so much for joining, and I look forward to seeing you in the next one.